Okay, guys, looking at page 30, we're going to work on some more maxima and increasing, decreasing practice. And you can see, hey, they've given me a function to graph and they want me to identify a lot of information from there. Okay, so I'm going to start by making this graph. My first thing is I marked 3 0 points on here. The first one is positive 2, 0, then negative 1, 0, and negative 2, 0. Okay, and you can notice that these are actually going to have some different shapes because of those exponents. And if we use our calculator, we can kind of get an idea of what this graph is going to look like. So if you have a calculator or if you're using Desmos, go ahead, take a second. Why don't you put this in? Remember, t is the same thing as x, and graph it and see if you can get a decent picture of it on your screen. Okay, and in red, what I've done is I've kind of just sketched what my graph looks like. It's not a perfect representation. I know that not everything is drawn to scale, but I did make sure to capture, hey, look, there's probably a minimum right here that's as my graph goes downwards. There is a maximum somewhere between those two zeros that we can see, and you can see that one end is rising and the other end is falling. Let's see if we can use this to help us solve some of our problems. The first thing it asks me is, hey, number one, what is t, where h of t equals 4? Okay, so again, remember, for this, I would draw a line across my graph at 4 to try and identify where that is going to be. So I marked it in green, and I would use my calculator to figure out exactly what value this is. All right, and if we used our calculator and you can use a little trace function, you should get that this is t equals negative 2.39. The next thing that we're asked for is h of 3, and we could honestly try to look it up from our graph, but it doesn't really fit super well on here. So we could also just plug in 3 or use our table, but we should find that h of t equals negative 100. We could either look at the graph and look at, hey, where is it when I'm at 3? And it's when we're way down there. You can see I'm marking it in blue. And what you could do is you could look it up from the graph, or we could plug in 3 in that t value up in our equation, and we would also get that it is equal to 100. And finally, the third question on this page asks us to find where there is an absolute maximum. Now, one thing to look out for, remember, our graph continues upwards with that arrow, okay? So this graph is not going to have an absolute maximum. It never stops going up. You can see, hey, look, there's my arrow. I marked it in blue, okay? So there is no absolute maximum on this graph. Okay, let's continue following along here. We're asked, hey, can we figure out where our graph is increasing, decreasing, and constant? So we're going to have to look pretty closely at our graph, and it may not necessarily be the best. So we may be relying a little bit on our electronic copy of this graph to help us with this, okay? So starting with the increasing section. So I'm going to try and highlight those. So the first thing, if we zoom in real close on those two zeros that were side by side, we're going to see, hey, there was actually a point where this has to turn around up here, okay? And that turning point can be found at negative 1.38 to 1.67. And that is actually going to give me my first increasing region here. And that increasing region, I'm going to go ahead and highlight in yellow. So you can see, hey, that is my increasing region right there. And that 0, remember that intercept was negative 2. So we've got negative 2 comma 0 and negative 1.38. So that's my first increasing region. Now that we've got that first one, I can kind of show you the second one here. And this one's a lot easier to see. It's a lot bigger. So you can see, hey, look, here's my highlighted section. That's another increasing section. And very simply, all we're going to do is we're going to look at where is this minimum value down here. It is at 0.58, comma, negative 21.2. Okay, so negative, or sorry, 0.58 and negative 21.2. That's going to be that one. And then my ending point up here is again, of course, this zero that is at 2 comma 0. Okay, so my next increasing region goes from 0.58 until 2. And again, we're relying on a calculator to help us find these values because they're not exact, so it's a little bit tricky to try and identify them. Okay, now let's try to identify our decreasing regions. And conveniently enough for us, they are in the exact opposite locations. Okay, so starting from negative infinity up until that negative 2, we can have our first decreasing region, negative infinity to negative 2. Then from negative 1.38 until that 0.58, we are decreasing. And finally, from that 0 marker, from 2 until infinity, we're also decreasing, right? So we've got 3 regions that are decreasing and 2 regions that are increasing. Now, in between those, each of our turning points counts as a constant region, okay? So we've got constants at x equals negative 2, negative 1.38, and at 0.58, and again at positive 2, okay? So those zeros, negative 2 and 2 were both turning points. Those count as constant values. And negative 1.38 and 0.58, which were my minimums and maximums that I ran into while doing this. Those were both also constants. Okay, now looking at part 5 on this question, we are going to talk about the domain, range, and where anything is discontinuous here. Okay, so let's start with the domain. Now this graph does not seem to have any gaps or shortcomings or holes in it. And so we can see that from left to right, I have arrow to arrow and no gaps in between. So I can say that my domain is all real numbers, or we could state it as from negative infinity until positive infinity. Two different notations meaning the same exact thing. Now, how about our range for this graph? Remember, we're going to look at our graph from top to bottom, or from bottom to top, okay, and look for any breaks in there. So again, I'm noticing, hey, there's a downward arrow to an upward arrow, which means I can start from negative infinity and go all the way up until positive infinity with no gaps or numbers being skipped. So again, we're going to say that this has a domain and range of real numbers, or negative infinity to positive infinity. And knowing this, I can determine that there are no areas where this is going to be discontinuous. So part C asks me values of t where h is discontinuous. And there are no t values where h is discontinuous. And we can kind of figure that out based on the fact that the domain goes from negative infinity until positive infinity. And so there are no discontinuities, no breaks in my graph, no gaps for that to happen. Okay, now 6, 7, and 8 ask you for some questions about the absolute minimum of the graph. And these are kind of actually a trick question, because look at these downward arrows. Are those going to mean something about my absolute minimum? Well, yes, definitely. Since there is a downward arrow here, we can tell that there is no absolute minimum. And no matter how I change this basic graph, there is no way for me to have an absolute minimum. So there's no absolute minimum for h of t. And for h of t plus 2, that's just going to move my graph left. There's still no absolute minimum. And if I moved my graph up 2, Is that going to suddenly create an absolute minimum? Nope, still no absolute minimum. So we're just going to have no absolute minimum because of the way this graph is shaped, okay? So even if you were to try and slide it around and move it up and down, that is not changing. That value just doesn't exist. There is no absolute minimum. And so we just can't have one. Okay, if we look at the next page and we see this graph, we're going to be asked some questions about it, and we're going to try and figure out the relative maximums, minimums, and some increasing, decreasing intervals for them. So let's start with problem 9, which is asking me about relative maximum values. Okay, so I want you guys to go look at this graph and see if you can highlight any relative maximum values on here. So you can see in yellow, I went ahead and highlighted two relative maximums, and those seem to be at 2 comma 5 maybe. And I'm just rounding, I'm not going to necessarily get exactly 5 there. And at 5 comma 6. Okay. Now, of course, one of these is higher than the other, but they're both still relative maximums. Okay. So where they occur is at 2 and 5, and what their values is are 5 and 6. Okay. Now, number 10 asks me to find the relative minimums. So same thing, guys. Pause the video if you know, and go ahead and try to identify those relative minimums for me. You can see that in blue I highlighted two relative minimums. It looks like negative 0.5 and maybe negative 7.5 as one of them, and maybe 3.2 and 2.1. Okay. Again, I'm estimating these decimals. We're just doing the best we can with our graph here. Okay. So those are relative minimum values. Again, my graph has come to kind of a valley there. Okay, let's continue working with this graph. Okay, we already identified our minimum and maximum values. Let's use those to help us find our increasing, decreasing, and constant intervals. Okay, so let's start with increasing. And let's again highlight the graph where that's going to be. So from down here up until this maximum, another section right here. Both of those in yellow look to be my increasing sections. So my increasing sections, following the maximums and minimums that I used, it looks like this one comes from that minimum that we had at negative 0.5. We found that minimum earlier, and it seems to go on until 2. Okay, so that is my first increasing area. And then my second increasing area is going to start from, again, where we said 3.2 was the number we had come up with, and it seems to go until 5. So that's my increasing section. Now, we can also find our decreasing section in a similar way. Okay, again, we have to use those maximum and minimum points that we found. Those are my turning points, okay? So let's see. Here are my regions that are decreasing. I've got this first section right here, this section in between, and then this third section right here. So let's see where we're decreasing. The first thing I see is the arrow. So it's starting from negative infinity, and it looks like it's going down to that negative 0.5, where I'm going to turn and go upwards again. Then from, it looks like that 2 until my 3.2, I am decreasing some more. And finally, my last section is starting from that 5 and going until positive infinity. Okay, so again, reaching this bottom arrow saying, hey, that section is also decreasing. So once we've marked them, we already knew what these points were. We came up with those earlier when we found the absolute minimums and maximums. All right, now where is my graph constant? It is actually at those exact points that I just marked. So down here that I'm highlighting in green. Okay, so those 4 values there are actually going to be constant. Okay, so let's state which x values those are. So I've got x equals negative 0.5, it can be 2, 3.2, and 5 are all constant values for x. So 4 different constants that we could run into. All right, and that's increasing, decreasing, and constant regions. All right, let's finish up. Let's state our domain range and the values of x where this is discontinuous. Okay, so very simply, guys, I've got a left arrow and a right arrow, and there's no gaps in between. So we've got a domain that goes from negative infinity until positive infinity. Remember, how else can we say that? We could have also used our little double R to say all real numbers. Okay, the range is also the same. I've got a down arrow and an up arrow, which means from negative infinity until positive infinity, or all real numbers. Okay. Now, are there any discontinuities? So stare at your graph for a moment, admire its beauty, and then tell me that, wait, there are no holes, no gaps, no breaks, nothing like that in my graph. So there are no values of x where f of x is discontinuous.